Team 3 always on time, it says. I think that's the team Isaiah's on, is what he's referring to. Wait. Who else is here? Strange. I hear someone, but Mrs. Riley's audio isn't on.
Hey, I don't hear anybody now. We're all set?
Good morning.
Good morning. Last morning, last day. What a weird semester, huh? Let me move, get comfy.
The last morning's the last day.
Last day of our class. So all you guys have left is your final after today. Get it all done.
14. Yep, last week of school after this.
Yep, almost done. Weirdest semester ever. I have the AT&T coming over today. So they're supposed to be here sometime today, so I figure they'll probably come during our class. So if he disconnects me from the internet, I'll get back on our Zoom session using my phone as a hotspot. So it won't be the fastest, but I can get back, I think. So hopefully he won't show up till we're done. But you know how that is. They always come when you want them to not. They were supposed to fix this a few weeks ago, but hopefully today it'll get all fixed and I'll have faster internet. Mine has not been bad, so I'm glad I'm not changing till the end of the semester because it's been working. Today, our last thing, we're going to do our glitch and image. And object-oriented programming is really the last thing that we were going to talk about.
I was having trouble on getting it set up with idle.
Okay. We'll do that today. So let's make sure we can get it all set up and get everything working for everybody. And then hopefully you can just have some fun with it, messing with it a little bit. Let's see, did you see on Discord what a couple of our super creative people had posted? I'm going to show you.
Yeah, I've seen the examples.
Did you see them? Aren't those awesome? So whenever RJ posted, let's see, first we have Isaiah's, which is really cool. What did you do to that, Isaiah? I'm not sure what he did. Anyways, we'll ask him. And then Chuck Norris. And so I thought, haha, Chuck Norris, you know, glitching can't affect him, but then it did. So that was really cool. Very impressive ones. You don't have to do anything that fancy. These guys just did some really creative things. I love it. Find the chat. Yeah. 15 years ago, well, whatever. It's still appropriate. Everybody understands the Chuck Norris jokes, right? We have whole giant websites devoted to it. It's so fun. I can't stand looking at myself like that, so I'm going to stop the video, move this out of the way so I can see our chat. And I wanted to collect our thoughts before we got started with this morning. And when we work with the image program that we're copying from GitHub, that source code, that script, approaches an image as an object. And so when we use that image library that we're accessing, instead of us reading our file, our image file, a row at a time or a record at a time, like we were seeing last time for file access, this approach allows us to access our whole image as one chunk, one object, one thing. And so object-oriented programming is just kind of a different way to organize our code. So the same code, still if statements, you know, function declarations, all those kinds of things that we've been learning about using, but just in a different way, organized around an object or an entity. So in this picture, this beautiful graphic here, we have an idea for a framework saying, you know, for our company, we deal with a lot of people, this mysterious person here. What if we had a person object? And by creating this as an—
Can you share your screen?
Oh, sure. That would probably help. You can't see my beautiful graphic. I'm glad you mentioned. See how beautiful it is? Thank you. Are you sharing? I'm not sharing. And you didn't see Chuck. Let me go back. I was just not showing you what I wanted to show you. So let's see. Here's Isaiah's. He didn't say what he did, but he did some really cool rearranging of some pixels. Very awesome. And then Chuck, you know, the first picture RJ posted was like, you can't mess with Chuck, but then he did. Ha ha ha. Okay, he's gonna show us later. It's awesome. So I think those are really good. And that's to me, the whole joy of using our glitch and image assignment is just a way for us to take some of the technical knowledge that we've learned and be super creative with it. The last couple of years, you guys might have heard about the Explore OTC event. It's out at the Ozark Empire Fairgrounds in that great big giant E-plex thing. And we bring through all sorts of high school students, just like hundreds and hundreds and hundreds of them. It's the kind of day where it's just really, really busy. And the last couple of years that we've done that, we've set up a CIS booth and we've shown people an opportunity to do a couple of things so they could use the glitch and image application to update images, or they can use a Raspberry Pi application to make LED lights blink, which I apologize, we have not been able to do because we've not been at the building. But it's super easy and it wouldn't be a problem for any of you, and anytime you want to do it, just let me know and I'll get you some stuff. But the thing is, the majority of the students that have come through have been more interested in glitching an image because they've already had a lot of exposure to minor, you know, engineering intro projects like that, like blinking the LEDs. And there's really not much to that. There's a little bit more to working with the image and glitching it. So I hope you have fun with it and kind of think about the artistic side, because that's what people are interested in nowadays in programming. We have so many opportunities for people to be artistic and to help others in the field. Artificial intelligence, all of those kinds of avenues that give people an opportunity to work with the medical field. Virtual reality is like one of the biggest helps we've seen for people with artificial limbs that that they've seen in ages. So we can 3D print some limbs, and then with our virtual reality, we can help people learn how to use them. So it's a great, great time to be in the field. So yay, stay. Good job, you guys have had so much to deal with. So this person object, thinking, gosh, I would like to be able to keep track of things about people. And some of the data that I'd like to be able to keep track of about the different people in our organization or in our group would be maybe their name, maybe their birthday, because our group is kind of holiday or event oriented. In our group, something that's really important is their weapon of choice. So we do a little bit of things that involve some costuming. And then we'd like to keep track of their address. So this is just a partial smattering of ideas of data that we could use. And we're going to say for our template that whenever we create information about a person, we want to keep track of these different data items. And then we want to allow our person object to do some things. So some of the actions that we're going to have associated with our person could be greet. Maybe we would allow them to attack and tell us what state their mood is in. So we can have all of these things associated with a person object through a template. And in object-oriented programming, that template is called a class. So we can use a class object to create this sort of framework. So over here on the left, we have a kind of a UML diagram. And UML, I'm going to throw all sorts of terms at you. UML stands for Unified Modeling Language. So it's just a way to try to visualize some technical information, kind of like flowcharts and data flow diagrams. It's just another sort of model diagram. When we're using UML, one specification says that to document a class, you could create a model that has the class name at the top, and then under the class name, it specifies what data items and the data types of those data items the class carries. And then lastly, we can have actions or functions associated with our class. The constructor is a special type of function. In our case, of creating a person, it's kind of like the birthing process. It's called instantiation. It creates an instance of our object. I'll show you a little bit more about that in a second. Now, besides the constructor, our class can have actions. So how does that work with our person framework? Well, our person, we're going to have data items of name, birthday, weapon of choice, and address. Whenever we create a new person, our constructor will be called person. Our constructor always has to have the same name as the class, by the way. And so our person constructor would ask for these different parameters: a string for the name, a date for the birthday, a string for the weapon of choice, and a string for the address. We might not give all that information to our constructor, or we might, depending on how our application works. Then we said our person was going to have a couple of actions, like a greet function and an attack function, and then we had that third one that I didn't fit on here that was returning the state of their mood. So a UML diagram can take a lot of different kind of forms. There's just a little bit of differences, kind of like a flowchart, you know? We don't have to be exactly perfect, but in general, I'm going to have class name at the top, followed by data items that my class carries. Those data items are going to have their data type specified. And then the bottom section of my diagram is going to be all of the functions that are associated with this person. Now, notice this is just a different way of organizing the code. It's no different than what we've already done. It's just that we're saying now, I'm going to organize all this code that has anything to do with a person. Now, if I want to use this someplace else, I can use it someplace else, just like I could use a string. Because basically, by creating this person template, I'm kind of creating a new data type that I can use wherever I want. So here's an instance of our person. We have one that is Javier. Here's the birth date, weapon of choice, address. Notice that the actions don't really change. All of our people know how to greet, attack, specify their mood. And then we could have another instance of our person object, Jacques. So every time we have a new person, they're an instance of that object. So when we're working with our image, every time we open an image file, that's a new image object. And when we're working with our image object, it's actually considered a two-dimensional array within that code that we're copying from GitHub. Within our image object, then, each intersection of a row and a column is called a pixel. And it's referred to as a pixel just like a picture element, just like we would see, reference to a pixel on a TV screen or a monitor screen. When we're working with a picture element, a pixel is normally assigned a color, and colors are displayed digitally as a combination of red, green, and blue. Now I have this link here in this PowerPoint, and this glitch and image PowerPoint should be on Canvas for you. I'm just going to bring up this web page, this color picker one, and it's not super fancy or anything. There are lots and lots of websites around that you can find that will help you find the different red, green, blue values for different colors. So looking at this color picker for this red color, it's giving me the hexadecimal value of the color code for this red color, but it's also giving me the decimal value. So I see my red, green, and blue value for this red color. If I pick some other color, it'll change those values. So you can use any sort of website like that to find out what these red, green, and blue color values are for a given color. Now, last time we looked at some glitched images. We can just never look at enough.
What was the HSL on that thing?
Do what?
HSL? I've never seen that before.
This website, it is htmlcolorcodes.com.
It says hex, RGB, and then HSL.
Oh, what is HSL? Hue, saturation, and lightness. So our image application that we're using doesn't really take those values into consideration. Isaiah is looking at one. What did you do, Isaiah? Have you used another application that does? Most of them would. Yeah, we could find a fancier image processing application that would let us update that. Good question. So, if I look at some image glitch art, again, different things are going to pop up depending on what we're looking at. Marilyn, like I say, there's a lot of Marilyn Monroe ones out there. She's always just a popular topic, lots of pictures available. For our example, we're not going to be overly concerned about copyrights. We're going to be just turning this in. So remember that if it's something that you want to post somewhere, that you want to make sure you're not violating any copyrights. It's kind of a gray area, isn't it? Because we are really, modifying that image, that starting image. So like if it were a computer program that were open source and we modified it that much, then we would have rights to that licensing. So you'd have to do a little bit of exploring there to find out that one. I'm not a copyright expert, so I don't know the answers, but I can say be careful there. These are really cool. So many awesome things that you can take. These are just pieces of material, textiles that people have glitched. A game startup screen. So whatever you would like to try. So to review, as we work with this image program, the image that we're working with is an object. We basically can grab the whole thing all at once. We're going to display that image in a window, and our window is an object also. So we can fiddle a little bit with our windows and our images. Whenever we're working with an image and it's become an object to us, the data properties that are available to us are going to be the red value, the green value, the blue value. So we'll be seeing that we can use accessor functions or actions to find out what the value of that pixel color is, like get red. And then we'll be able to use update functions or mutator functions that update those values so that we change the value of that pixel. So as we're writing this code, I want you to be thinking about those things that are happening. We are accessing the image object data, and then we're updating the image object data. It's not really much code, but that's what's going on behind the scenes. And then we can use functions like get and set to change the behaviors of our window and our image. Let's try it. Now I've got a link here that is to that Runestone page. I should still have it open. I only have a few things open. And we were looking at, get back up here, section 8. And in section 8 is really more about looping. So it's a really, really good section, but we kind of skipped down to the two-dimensional iteration where we're looking at our image. And then 8.12 is where we saw the code we could get from GitHub. So I'm going to go to that spot. Now, before I go here, let's go create some folders for our image project. I'm going to go to File Explorer because last time I used Atom to create a file folder for our project, but I know we have a few people that are still using idle, which is not a problem. So let's create our folder structure outside of our editor so we don't have to worry about which one anybody is using. Now I have mine set up on my OneDrive, and it's in my documents folder, my 120 folder, and my Spring 20 folder. And then, of course, I have one more folder in there because that wasn't enough. And then I had created a new folder called Image Glitch. I'm going to delete that one so that we can create it again. So I want a new folder, and I'm going to name it Image Glitch. Now I want to open that folder And what we're going to create is image.py as a file. So we could use anything we wanted to create this file. Let's go find it and take a look at it in GitHub and see what we can do. First of all, in our document, they say you can download cimage.py from the GitHub page. Well, let's go look at the GitHub page. The link. Now, GitHub is just a place, a source control library, a place where people in the cloud can save their code and share it with others. And they tell us to get CImage. And they say all these weird things. If using Thonny, I don't know what that is. We're not using it, right? But we could go install some things if we were. If we're not, which we're not, they say copy image py to your directory or keep it in the same folder as the Python scripts that import it. Okay, that's what we're going to do, is keep it in the same folder. So we just want image.py. Now, if I look up here at GitHub, I can download all of these files as a zip file, but that would give me a lot of things that I don't really need. Maybe they would be great things, I don't know. But all the instructions so far say all I need is image.py. So I'm going to click on that file. Now again, GitHub is changing all the time. So I'm just looking, I'm like, oh, is there something that I could do to make it easier to copy this file? Not yet, but they're getting there. So I'm going to click on raw because I want to see the source code, the raw code. Okay, now that I've got the raw code, I can select it all, Control A, and then I'm going to Control C to copy it. I guess I'll go ahead and open idle. And I'll say that I want to create a new file. And now I'll paste all this code. Now, if you want to, you are welcome to scroll up to the top and look through the code in this file, but you don't need to. Some of it is going to be things that are meaningful to you, and a lot of it won't. But what we do need to do is save it. So I want to file, save as, and I want to save it to my folder that I just created. So it's on my OneDrive. Image glitch. And I want to name this file image.py.
Lowercase I.
Lowercase I. And the reason being, they give us a lot of different names for this file depending on what we're looking at. So I'm going to always make sure I match what they say in the comment up here. And it might, you know, I'm sure that we could find a place where that doesn't give us the correct information too. But for this one, we'll go with it. Image.py lowercase, and let's save. Now we can close this file. We don't need to look at that source code. We just needed to get it into our project folder. I'm going to go ahead and close idle and return back to Runestone from GitHub. Now, in this GitHub folder, there are some other things. There's like some code for turning things grayscale. other examples, you know, some of the examples that we're seeing online in Runestone. So we could get some of that information here, source code wise too, from GitHub. But that's what we needed. So we've got the image file now saved. And I think that I'm just going to go back to previous and copy the code that they give us. Find the right one here. Okay, so find this code, activity 7. And this one doesn't do much fancy stuff here. But we want to copy it all, so make sure to copy the whole thing. Copy. And then if I'm going to use idle, again, I'll create a new file and paste. Now looking at this, I'm using this luther.jpg file. I don't have that file, and I'd like to try something else. So first let me save this. File, save as. Make sure I put it in my same image glitch folder. And I'm going to name this one. We thought this one was like a reverse video, right? Reverse.py. So I'd like to go find a picture. So I'm going to go find something. And we need it to be animated. Because of some limitations with that image library. So let's find something that's animated. I'm going to let you take a look, see what you can find while I find something else here. I have a bunch. That's what I wanted to find. There's one that I just like. It's old too. Oh, Isaiah says, what did you convert it to? A GIF? And it's, you can do all sorts of things. And I just like this baby Groot. I'm gonna go find baby Groot. But I want it to be animated. Cheapo, look at me just clicking on things in Google without typing stuff. Well, I know there was a baby Groot that I really liked. He was super cute. And he, I probably won't be able to find him. Somebody's saying, just go to giphy.gif. I know, but I really liked it. Okay.
Oh, no, I uploaded a file.
Did you upload one? What is it?
It's just an animated file.
Is it good? Should we use it?
Simple.
Let's try it. I'm going to click download on the chat and then save that to the same folder where I have all my other stuff. Maybe. There it is. Okay, so we're going to put this GIF in that same folder. And now I'm just going to change my file name. Giphy.gif. Let's try to run it. Nice. It's very, very nice. And way too big. So how can I get it to stop? I'm going to go ahead and click the stop and tell it to close. And then close our window. Yes, I want to kill it. We should be okay and back to our code. So I want to find something a lot easier. Let me send you this little one, a lot smaller, just because that's a beautiful picture. And we need something that'll be quicker. Yeah, that looks really cool. So what we did for the Explore OTC activity, we actually made a lot of the images much smaller. And we edited in Photoshop to kind of remove all of the different images except for one. So it was still a gift, kind of tricked the program into using it. But it was like not nearly as long execution time. We are definitely seeing some execution time with this stuff. We see how hard it can be. Okay, I'm going to put the baby Groot into my image glitch folder. And then I'm going to change my code to look at baby Groot. And hopefully he really is small. Let's try to run it. It's a little bitty. I can't tell what's going on. Can you tell what's going on? Boy, it sure would be nice to be able to see what was happening as it was running. Let's check our code. Oh, there he is. He got done. But I'd like to be able to see it real time. Could we do that? Sure. How's everybody doing? Okay, you got an error, Vincent. Let's see it. Let me stop sharing here so we can get everybody working. I know, slow the program way down. Okay, Vincent, let's see what you got.
Says idle subprocess didn't make the connection. See the startup file selection of the idle doc online at docs.python.
Let's see your code. Oh, that looks good. Let's, in your folder, we've got baby Groot. And did it make you save it before it ran?
Yes.
Try to close that Python shell. Oh, I think you're okay. Try to run it again after you save it. What is that purple screen behind you a picture? Is it showing something, or is that your, no, the one over here beside idle? Oh, okay. I was thinking, is that your image? So let's close idle and open it again.
One might do. Well, that's not. How to do it. Okay, so I now have the code opened up.
Okay. So run it again. Okay, so it's running. It just is going to take a really long time to show you the update. So that's why I was saying I think we should do something in our code to have the window automatically refresh so that we see what's going on. So I think you're good. So kind of ignore those warnings and errors you're getting back there because I think you're okay. It's just that it takes a really long time to run. So hang on. It should do it. It should do it. Is it going to pop up with the new one? Come on, baby Groot.
It's a good size and it slows it down.
It is slow. We'll cancel it and let's make these changes and we'll see if we can tell what's going on then. Okay, I'm going to take back over here for a minute and put this code in and then we'll be able to tell more of what's going on. Okay, you guys are over here discussing how this is going to slow things down. It sure is. What we want to do is right now we have one image. So this is our one image instance. And then we have a window, one window instance. And whenever we create our window, we're just saying how big we want it to be. So we want it to be the same width and height as the image that we just created. Now, after we create the window, we are going to use the window to display our image. So how can we say that? Draw the image in the window. That's kind of how that code is. And then the set delay. Now, this is what you guys were talking about. Delete the set delay function. That doesn't work. So that would be some sort of problem with that code that we grabbed. All right, now we've got our image all set up in a window. What if we did a second window and we put our new image in it? So many ways we could do this. Let's say our image new, we're going to set it equal to our baby Groot image also. So now we have two instances of the same image. We can only see one of them though. So if we want to see the second one, we have to create a window for it. So let's say our window new is going to be a window that holds an image. So find it from that image program and set up the window and use our get width and get height to set up the size. And now we're going to say, I want to draw our new image in our new window. Now, if we ran this right now, we should see two windows side by side. I don't want to quite run it yet because we don't have any action happening. Now, every time we are working with our pixels here, we're really working with the image, IMG. We can go through and change all those instance names, but that's a bunch, isn't it? Maybe instead of image new, I should say image old here. Image old, and then our window old, image old. Just messing with you. So each of those places we had to change that instance name of the image that we were creating, the image object. So I was thinking, oh, we want to create a new version of our image, but actually we just want to keep track of the old one because we already have all our code in place. So create an image object to update, create an image object to keep track of the old one, create a window to show the image, and then create a window to show the old original that won't change. Now, in our for loops, right here after we update our pixel value, we could update our window so that we see how that image was changed. Let's try it. img.draw win, because that's what we are doing to display the window that has our image. Now, if we do this, we're going to be updating this image for every pixel. It's going to be really slow. Let's save because we'll probably have to cancel out of this. And I used to work with a friend who has a business that does a lot of image processing, image art, and it is just slow. We could use she could buy a brand new computer and it would still just bring it to its knees, wipe out hard drive space. Working with images is huge. All right, so let's try it. I'm gonna run this thing. Okay, now I have my two baby Groots. It would be nice if we updated our title or something of our different window instances, but that's okay. Now, can you see this baby Groot over here, how it's slowly changing? Now, very, very slowly up at the top as it's going across a pixel at a time.
Wait, I only
doing
have
that
one
reverse.
window.
Do what?
I only have one window.
You only have one? Let's find it. Is it right on top of the other? See if it's right on top.
No, it's not.
Okay,
It's
we'll
not
fix
even,
it.
It's not even, it's only displaying one window.
Okay, well, we got to make sure we display them both. Hang on and we'll find it. So we're going across. Everybody get the idea there. It's going slow as a dog. We can't have it work that way. Plus, Vincent's isn't working that way anyways. So let's change it.
There's no emergency thing.
Let's check your code. Now it got mad at me when I canceled. Okay, so check Vincent right here. Make sure we're doing the image draw on win, and then the image old draw on win old.
Still just one. And I can't share my screen to show you.
Oh, here, let me stop sharing. Okay, you should be able to. Okay, let me see that code.
See, I only have one.
Uh-huh. Okay, so we've got image old. See the second time in the win old, look at that word width. And it didn't give you a good error, at least about that. Let's see if that was what was doing it. There we go. So it didn't come out with a good error message. It just kind of didn't build that window right. Has anybody found a GIF that's better, that is more visual? I don't like the way this one is being very hard for us to see. I think we can find a better one. Let me see what this one is here that I've got. Oh, didn't like it. This one's good. I'm going to send it to you. It's not huge. It is small. The reason I want to try a different image is because the image that we're using just doesn't have a lot of different colors. And so it's kind of hard to show it working. So I'm going to grab this sun GIF. And then I'm going to change my file name, sun.
I can't see your screen.
Oh, thank you, sir. Okay, so the one that's in the chat, sun.gif, is just a little smaller, but it also has a lot more colors. So let me run using sun.gif that I copied from the chat. And hopefully we can see the reverse video happening a little bit more. I'm getting a red line now instead of just a black line. It's still kind of hard to see unless we watch it for a little while.
Yeah, I see it.
Can you see it better? That other way, we couldn't see much happening at all. If it starts getting down into the sun, it gets to be a lot more obvious.
It's like 1 pixel tall.
Yep.
Now it's increased to 2.
Yep. So we can see the way the loops are working, our inner and outer loop. We go across each line, and then we go down a line to go across each line again. All right, I'm going to close it. So, too annoying, what we could do is redraw our window. How about if we just redraw it every time we get done with a row? If I back tab and move this statement outside of our inner loop, then we're only going to redraw that window every time we get a new row done. So let's try that and see if we can watch it a little bit easier. Now, notice how much faster that makes it if we don't have to watch every single pixel being changed. So we learn a lot there, right? Not only just about inner and outer loops, but about the fact that every time we interact with the screen, the console, it really costs a lot of resources, doesn't it? So that's just an interesting thing to know. I like the reverse video, son. It's kind of interesting. All right, so now we have our input screen and our output screen. I don't mind that. What do you guys think? I think doing every row is pretty usable. We're going to be able to see what's happening. We don't just have to sit there and wait, wondering if our program is working or not. So that's kind of handy. Everything looks good there. Everybody okay with size? They used to have problems in their sample code where they had the height and the width crossed over, but I think they've got that fixed. Okay, so we saw here that this was going to do a reverse video kind of thing. So if we copied our for loop and we pasted it, we could comment out this first one and say, this does reverse video. And now we're going to make this one do the average. So we did that really, really quickly last time, but it was like too quick. So if we want to do the grayscale, they mentioned that a grayscale is an average of the red, green, and blue pixels. So we're going to calculate a new variable called average. Whenever we create above that an instance of a pixel, or we don't create an instance of a pixel, we actually just say, I have a variable P, and I would like for you to get the next pixel at this column, at this row, from my image, and place that pixel into variable P. P will contain this pixel. And for a pixel, we said that a pixel has a red, green, and blue component. So we can take the average of those. For P, which is our pixel, we would like to use the getRed function. Then we would like to use the getGreen function for that pixel. And then we would like to add in the blue. So we can add all the pixel values. And then we can update our average to say, okay, well, we'd already added up those values. Now let's divide them by 3. I'm just going to make this long. And then we can say, hey, wait, things aren't going to work right because this program only takes pixel values that are integers. So we can turn our average into an integer. I could have done all of those things with that one line of code, right, in that calculation. I just wanted to annoyingly remind you that I could also do them all separately if I wanted to really, really get down to the basics and keep things as simple as possible. Pixel must be an integer. Now, we saw that last time very quickly when we were trying to run, that if we didn't make that an integer, then we could have trouble. And we would see the cancellation down in the image code, and we would think that there was something wrong with that program. But it would be us passing an invalid value because they don't do good data validation in that program, right? We already saw that with that problem earlier. The width value was not being passed in properly, and the program just didn't work right. It didn't really say there was much going on. So we have to make sure that we're passing good data. Now, next, we're using where am I? The new values of the pixels to update this pixel. Well, we don't need to do that. We could just do the average for each of these now that we're grayscaling, now when we use the set pixel function, we'll have our pixel that has these new values, and we'll be updating that pixel by setting it to those new values. When we get done with all of the columns in a row, we'll redraw our window and go down to the next row. I want to put a space here after we do that. All right, so let's try and run this again. And now we should see our sun in grayscale.
The windows aren't changing.
Do what?
The windows aren't changing.
Is it working?
No, it is not.
What's it doing? Let's
There is
see.
no difference.
Well, my
I
goodness.
cannot show you.
Well, just a second. Okay, now you can.
Whenever I run this, there is no difference in the windows.
And the other one was working, right?
Yes.
Put a space before the pound sign or the hashtags on the where you're assigning the new values. It shouldn't matter, but try that.
I think this is something that we have to go to Python tutor for. Or whatever the site was.
Yeah, I don't know if it'll help you much because it doesn't do very good with the images. Oh, he says it's the get green. Check your code. Let's look at your get green. Oh, there it is. Ho, 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 good eyes. Josh sees it right there in your get green. It's missing the opening close parentheses. Good job. Try that.
Now it works.
Woohoo! Thank you, Josh. Looks good. All right. Okay, so lots of things that we could do. When I look at this, I think, oh my goodness, I could create a function that does all of this updating and then just call it, and I wouldn't have to worry about all these other things going on. That's true. I could do some stuff like that. But I'm not going to. I'll let you do it. What I'd like to do is think about some other things that we could do to alter this image. What if we decided that we wanted to have like a row of like a row of a different color just going across from the top to the bottom. I'm going to create another set of code here, and I'm thinking about it. So whenever we calculate our average, we're using that to update our pixels. Well, what if we do a little bit more there? So after we update our pixels, before we use those in our new pixel, let's try a little bit of finagling. What if whenever our row equals our column, we set our new pixels to something different? Let's say new red equals 255, new green equals 0, new blue equals 0. This is going to be small because we're just doing a specific pixel where the row equals the column. So I had to watch closely to see if we can see this red line. So I'm going to run it. So I can see it coming. So since we said if row equals column, we're getting a diagonal red line across. You get that? So that's an easy thing that we can add, another glitch. And if you notice, I put that after our average because I wanted to still use the grayscale modification, but then I wanted to add this red line. Now, what if I move that? I'm going to move it. What's going to happen? You guys are good programmers. Tell me what I'm doing wrong here. I'm going to move that if statement. And now if I run, am I going to get my red line? And I still have the code in, but I'm not getting my red line.
It's because average is overriding the color values.
Exactly. I have things in the wrong order now, so I'm not being able to update that properly. So I'm going to Control Z and put that back. So I always have to make sure that my updates are happening in the correct order, the way that I want things to happen. Now we could add in some reverse video if we wanted to there, and make like a stripe, a reverse video, a stripe of the grayscale. Let's try it. If I say that I want to just do it a few times, how about if row is greater than 35 and row is less than 70. Then I want to do the reverse video. So I'm going to say my new red is going to be equal to 55 minus current red. And our new green, 55 minus current green. And our new blue. So we can use these functions of this object-oriented script without even really thinking about it. So anytime we're using this dot type syntax, we're saying object name dot function name. So it's just the same as us calling a function within our actual script, except that we have to prefix it with the name of the object that we've created, which is P for pixel. Okay, so now if we look at our logic, we're going through all of our rows. For every row, we're going through every column. For every column, we're getting a pixel. We're setting the grayscale. Then, if we're going across the diagonal, we're going to update and just use a red instead. But if we're between rows 36 and 69, we're going to do a reverse video instead of the other things. So let's try it. Okay, so how did that work? We've got our grayscale right kind of in the middle, our little splotch of reverse video. Dot subfunction, a function within a function. Oh, Vincent's asking, actually it's a function within a class. So you could probably have a function within a function too, getting deep with things. But anytime you're looking at a dot syntax like that, you're talking about something that is within something else. Okay, so since everybody's working all right, getting some different glitches going on. So this one does give us 3. We could do lots of other things. We could generate a random number for our, row and column, and then we could decide to set, everything that is evenly divisible by the random number to black, to have some black spots around, black squares, so many different things. So lots of stuff you can do. Questions? Sure, we can do that. So let's say we want to get a random number, and we're going to use it right before we go into our for loop. I have to import that random library, huh? How do you do it? I always have to look it up. Because I just don't remember that. That silly syntax. All right, so I want a random integer, but I want to use the limits. And the limits I'm going to use should be what, our width or height or something. Oh, RJ, that's cool. Let's try that thing that RJ said he used. Did you just do that everywhere in your whole thing? Ah, a few places. That's a great idea. I'll continue on or else I get all messed up. So I'm going to say, well, I would like to just have a random integer that is going to be somewhere within a row. So I'm going to use our, whoops, 1 is our beginning and our ending will be our get width. And I need our opening and closing parentheses because get width is a function. So that's going to give me a random number. And then I can just, I'm going to go ahead and let our grayscale happen. We're getting a little bit stringy here, but here we've got our grayscale happening. And then after that, our second process is doing our red diagonal. Our third process is setting that reverse video for a band. So I'll add this in as a fourth process. Let's say we've got this random number and we want to decide if this column is divisible by that random number. I don't want to use that name random, sorry. How about random? Get myself in trouble using that keyword. So we're going to check to see. So I'm going to put parentheses around that formula. And if our result is 0, we know that we had no remainder. We're at a column that is evenly divisible by our random number. So some sort of multiple of our random number. So nothing that we have to be real specific about. But I'm going to go ahead and set our values to 0. Since we saw that that was black. We should just get some splotches. Let's see if it works. I'm just getting a line. So this time, my random number was so high that I didn't have anything that was divisible throughout the column. I'll try writing it again because I should end up like in a different space, a different spot.
I got 7 lines.
Yeah, I do too. Now I've got a bunch more lines. So just random lines. This didn't end up random splotches, random
I think
lines.
it's because the random numbers roll different numbers than ours.
So you're all going to get different.
Lines.
Everybody's different. So looks like my poor sunshine is in jail trying some things. So we could do something a little bit different because that just came out with lines. So what if I said, if I tried to do something else, and I said, well, what if I multiply my column times my row, and then divide by my random number? Is that going to give me more like splotches like I'm wanting? Let's try it. I do. I'm getting a bunch of splotches along with this line and some other lines. So you can kind of tell where what your random number was, right? So it's like geometry in action. But I can see my black splotches around. They're very well organized. So lots of different things we could try. So just try some stuff because it's so neat how things work.
Oh, now I have a dotted line along with my other black line.
Try some stuff. So let's see what you can do. So yeah, this one I would love to be able to see what everybody's doing. This is one of those times where I wish I could walk around and see your monitor and see what you're doing. And I could have you guys all share, but it won't let us share to where you can see each other. So that's kind of makes it not work as well as I would like. I'd like it to where I'll make that suggestion to Zoom. How about you guys do it too, where we could bring up the Zoom panel that shows all the faces. It would be really nice if we could bring that up with everybody's screens so that we could see all the screens all at once, so we could see what people are doing, because I know everybody's coming up with some really cool glitches that I can't see. So I'm excited about seeing your assignments get turned in. Most everything is graded, except I think the last one little thing before your final. I know there's some people that have some things outstanding. Remember, grading time is limited, kind of like your time to get things done. So can't really grade past the time that grades are due. So let's get all that turned in. Your image glitch, I'll grade very generously. Like I say, to me, this is a creative thing, and I want to see what kinds of things that you come up with in your code, because that's what's cool about it. So that one is not one for you to really stress about. Just get something turned in, enjoy it, try to visualize some things to help you really get some of those concepts in place. Our final, again, will be the same question bank. So the same study guides that we've had before should be applicable. Your hands-on component will be points added directly to your final score. So kind of bonus points again. Any other questions before we let you guys have some time to get this one done and turned in? any other things? No other things. We guys have just been a great class. I've enjoyed it. You've done a great job at coming to Zoom sessions and trying to keep your learning up to speed. I see a lot of you signed up for the summer C# class. I think that's a great idea because some of you just have a really, really good handle on some basic concepts, and that's going to go good.
Now can you hear me?
There, I can hear you. What's going on?
Oh, I've been saying things, but nobody's been
We
hearing
couldn't
me.
hear you. Oh no.
Well, I was gonna say if you wanted me to show mine, I can.
Oh yes, yes, I do. Let me stop the share so you can do that.
Sure then. Let's see here. I'm just gonna do this and have it reformat everything. I'm going to grab Atom, which is a different class right now. I'm gonna go into my image glitch folder, find my image glitch.py. I'm gonna open with Atom. Let's see here. That looks like it opened in the same page. Come on. Oh, right, you have to do a new window. Some things that I don't like about Atom, but
I'm just
I
excited.
like the fact that it just duplicates the window. Come on.
Yeah, I like that. And I like the fact it's working with our image glitch stuff where it wouldn't before. So yay.
Just get that out of my face. Now I have 2 copies of this. Let's get rid of that. So basically what I did for my glitch is made a 2-axis bubble sorter, which basically means that I go through the entire list and I look for horizontal and vertical neighbors, and if the hue of one of them is greater than the hue of the other, then I swap them.
Oh, neat.
Which is what a bubble sort is. You examine 2 things. If one is higher than the other, then you swap them, and you just keep doing that until eventually they all go to the right spot.
Uh-huh.
It's not a true sorter because it's 2-dimensional and whatever. I also had to do this weird thing that since I did a test, and I know I did like a test like 10,000 times, write a pixel to an image, and that took 100 seconds to do. So the like set pixel function is ridiculously slow compared to all the rest of this. Like I can run this code here, which is just I guess I should just explain from the top basically, but I went through the entire image, the entire width and the entire height, and I created a kind of fake image that's actually just an array of the pixel's RGB value and this hue function, which is what I mentioned earlier, but didn't come through because my mic was off. When we were talking about HSL, I said, oh, I made an implementation where I can put in an RGB value and it will do the math and give me a HSL value, a hue value specifically.
Nice.
So that's what this function does. So I do the hue and that, and then it goes through, and instead of swapping the pixel colors, it swaps the components of these arrays. Like, what's in what thing. And at the very end, it takes all of that and rewrites it back to the image. So let's see here. I'm going to do a smaller image here. I had a larger image. It's kind of a glitchiness component. If you let it sort all the way, it'll just kind of blur the image into a bunch of lines.
Oh.
But halfway, it looks a whole lot cooler. So that's, what's his face, like a 20th? It's going to give me a very small image. Oh, so it just barely messed it up. You see it moves some white pixels down and some black pixels up and whatever, and there's kind of this border of things. Let me make it just a little worse because that did not take very long to do. But now, it doesn't write anything at all until the process is at the very end. There we go.
Oh,
you
cool.
see how it's kind of slowly smears everything across the entire page and moves all the pixels around so that eventually it'll just condense. So if I set this to 1, it'll take a whole lot of a long time, but I mean, not terribly long, I guess. And of course there you go. So it just kind of
Cool.
blended the entire image into a line graph of all the different colors. And you could do it on any old image. I just like the way that it looks.
I like it.
So I'll turn off the zoom.
Very, very awesome. That is so good. Let's give him a hand. Let me find my hand here.
This kind of hand.
There it is. Yay!
Oh, it's that kind of hand on.
Second
There we
hand
go.
on your participant screen. Yay! And then you have to turn it back off, otherwise it just keeps being there. Someday everybody's going to actually use the little away clock to let me know they're gone. We have so many checklists. We do not have class on Tuesday. Thanks, Michael. Good question. We will not have class anymore. Today was it. This is our last day. So just make sure that you get your final taken and turned in by next Thursday night, and your hands-on turned in by next Thursday night. Fit that in with your other classes and your other finals, and you should have hopefully enough time to get everything done. Let me know if you run into any problems, because there, it is a lot of changes in Canvas to update things to make it to where you guys can take your final online. And so it's always possible that I miss one of those settings or something and it doesn't let you. So let me know. There's the practice tests. Use the same practice tests that you've already had. And Chelsea, you should be able to take the final starting at midnight tonight, because that will be I'm just going to go ahead and open it up for the online final window. I know some of the other instructors are doing it a little differently date-wise, but I thought that you guys should just have that whole week that's available to people that are in online classes. So it should be available tonight at midnight. If it's not, do let me know. I'll double check. Other questions? I know you've got them. We talked about using your notes. Your study group notes are fine for a resource with the final. Your code for your final project. We were talking that you probably would have to refer to the internet. So your sample code first, textbook second, internet third. What else?
Isaiah is asking about the practice test for the final.
She
Yeah,
already answered that question.
use the practice tests that were out there for each unit exam, and they're posted in Canvas. So you should be able to find all those.
So just to reiterate, you did say that we could use sample code if we needed to, and then refer to the textbook or internet, or just the sample code?
You can use all for your final, because we just haven't done the turtle thing enough for you to not need to refer to the internet, if that makes sense. So,
Okay.
yeah, that's fine.
So just try not to use it for the whole thing, but it
Right.
we need it.
But you're gonna probably have to refer to it, especially for the turtle one.
So like we could go to Runestone and use like resources we've been using if we wanted.
Yes, yes. That would be fine. And then the object-oriented components that we were just barely looking at, if there's stuff that you would like to practice on over the summer, the chapter 11 in the Prelude to Programming book is object-oriented. Chapter 15 in the Runestone material talks about creating Python apps with a graphical user interface, kind of like forms based. Then chapter 17 starts with object-oriented programming. So that resource is available to you anytime. That Runestone is all free. So if there's stuff that you would like to practice on over the summer, if you're not taking classes, do go ahead and take a look at some of those chapters. Remember, any practice is better than no practice. Even if you go back and write, a Hello World program, that's better than none. Other questions, comments for the group? You guys are just the quietest bunch, like you always were in class. You guys are just, go ahead.
I'm surprised you get classes that are more talkative.
Do what?
I think of, I don't know, every class I've ever been in is like this, where absolutely nobody wants to talk. Like, I'm an extrovert and all, but it seems pretty normal.
Does it seem normal? I'm not ever in any of those other classes, so I'm always like sometimes computer stuff is dry. And so whenever there are questions and things, it seems to break up some of the dryness. So I like that. I like questions and talking, but I think that you guys have just been the best class ever. And not just because we didn't have to get together for the last part of the semester. You've been quiet, but you've asked questions when appropriate. You've all done a great job on assignments. Let me know if you needed help. So that's all great stuff. Let me know if you have any trouble. Let me know, honestly, at this point, let me know if you have any trouble. A lot of you are on my list of advisees. I can help you with scheduling throughout the summer. Don't forget, OTC has gotten just recently some grant money awarded that's going to be dispersed directly to students. There will probably be opportunities for new scholarships and things that weren't available before. So be sure to be keeping your eyes peeled and be watching your email for those kinds of things, especially if you got a Pell Grant. I think that for sure they've already decided that Pell Grant recipients will be getting a disbursement. So be watching for those things. They're not all just bad news. They might be trying to give you money. So watch your email. Everybody okay though? As long as everybody's good, I'm gonna end this thing and I will see you in C#. Bye. Bye, thanks.
Bye.
Bye, have a great summer.
Bye, guys.
Thank you all. See ya.